Hello and welcome to this 3DO webinar preview. This is a small sample of the original presentation, but if you'd like to view the full webinar, please click the link in the description below.
Thanks so much for joining today's webinar. My name is Matt Sand, and I'll be presenting on design freedom and manufacturing flexibility. I'm really excited to share a case study with you of a customer we work with and how that really kind of showcases and highlights the possibilities for manufacturing flexibility and freedom with 3D printing. I'll just dive in quickly with an introduction to 3DO. We are a serial production metal additive manufacturing service provider based in Los Angeles, California. And on the screen, you can see a few of the high volume parts that we make for customers. We are one of the largest by quantity metal 3D printing service providers in the world. And we sell parts. We invented a new technology, as you can see in the middle picture, but we actually don't sell the printers. Instead, we own the end-to-end factory production line, and we use our printers and our unique technology to make parts for customers. We only make parts in production in 17.4 pH stainless steel today, and the reason for that is we've really focused on delivering excellent quality parts to our customers. The ideal part size, as you can see for us, is small. It's 1 inch by 1 inch by 2 inches. And the reason for that is at that size, assuming complexity in a part, we can be cost competitive with CNC machining and metal injection molding. In fact, our tolerances, our surface finish, and the material properties of our parts rival the best of CNC machining and metal injection molding. There's our website at the bottom there if you'd like to learn more about the company. I'm the co-founder and president of 3DO. For over 3 years, I've worked with customers in hands-on applications and moving parts into production using metal 3D printing as the technology. I'm a serial entrepreneur, so I've started a lot of different companies in different industries, and I was also an officer in the US Air Force. I have an MBA from UCLA, so don't hold the MBA against me, but you'll see that my focus is more on economics of additive manufacturing and how that can succeed in the marketplace. So for today's agenda, I've got 5 key points that I want to talk to you about. The first, for those who are new to 3D printing, we'll quickly cover what is 3D printing. I'll talk about design freedom and what 3D printing or additive manufacturing brings to the table in terms of design freedom. We'll talk about manufacturing flexibility on the factory floor. As you're making parts, what type of flexibility do you gain from using 3D printing as your core fabrication technology? And then we'll dive into the case study, which is Ergo Kiwi, an ergonomic X-Acto knife for architects and others needing cutting capability. So we'll talk about that specifically in the context of design freedom and manufacturing flexibility. And we'll finish the presentation with how to get started with 3D printing. So with that, let's dive in. First, what is 3D printing? Well, 3D printing is the process of quote unquote growing a part layer by layer. You build the part on top of itself in layers, and eventually, as you can see in the image here, the full part is fabricated. So it's because you're adding material on top of other material that they call it an additive process, and that's as compared to subtractive, which is cutting material away from a block of metal, for example. So in a nutshell, what you do is you start with a 3D model. As you can see the 3D model on the screen there to the left, you design it in CAD and you have it mocked up exactly as you like. And then the printing process starts with what's known as slicing. So we slice that 3D model into many 2D layers. And those 2D layers are then stacked on top of each other until ultimately you have the entire part. Those 2D layers are printed layer by layer in the 3D printer, which you can see off to the right in the back there. And then post-processing happens from there. And post-processing is worth highlighting as kind of the dirty little secret in 3D printing. We are far from the Star Trek replicator where you just push a button and the part comes out. Actually, post-processing is a significant portion of the cost and something to be hyper aware of. So I have this video here that I want to show you of plastic FDM printer, which a lot of you have probably seen and are familiar with in action. As you can tell, the video is dramatically accelerated when you compare it to the actual speed here. But I accelerate it just so that I can show you what it actually looks like. There's material feeding into the printer, and layer by layer, this part is being grown until it's ultimately done, and the character here is fully printed. So that's an example of 3D printing. Of course, this is plastic 3D printing, not metal. 3DO does metal 3D printing, but the general principles are the same. Carbon 3D has gotten a lot of attention, and specifically because of the speed of its printing. If the other video was sped up by 200x, this video is only 7x faster, and it gives you an example of how fast 3D printing is getting and the type of complexity we can achieve from 3D printing. You're able to gain that complexity because you're growing the part layer by layer. This is a pretty famous part because it was printed during a tech talk by the former CEO of Carbon 3D. And it was printed during the talk in the background, so it's pretty cool. You can see the complexity of that part as it comes out of the vat. So that's another technology on the plastic side, but let's turn our attention now to metal. What you're seeing before you is the GE fuel nozzle, which is the poster child for metal additive manufacturing. It's not the entire piece that you see, but just the tip of this component. And it was previously 20 parts, it's now 1 part. It's 25% lighter, in addition to being 5 times stronger. And the new design is realized because of additive manufacturing. Most importantly, when it comes to aircraft design, 15% more fuel efficient, 10% more thrust. So you get all these benefits from working with additive. And as a result, this is one of the biggest success stories when it comes to metal 3D printing. Another success story we see are completely custom titanium hips, knees. So these are implants that go into the body. They can be titanium, they can be cobalt chrome, but this is a great application and a huge success story in the world of metal 3D printing. When we focus on metal additive manufacturing processes, I just want to throw out there that talking about 3D printing of metals is a very broad category. There are many different processes that fall into this category. Powder bed fusion is commonly known as DMLS, is one type of powder bed fusion, direct metal laser sintering. Binder jetting is in the media a lot recently. There are some new binder jet processes come on the market. Extrusion is finally here for metals. So that's the FFF or FDM type of deposition. DED, material jetting, and then intelligent layering is 3DO's unique and proprietary technology. And there are also more on the way. So these all fall under the category of metal 3D printing. And understandably, if you're new to it, it can get pretty confusing. But it's worth working through the difficulty to understand what the technology can do. And here's why. This is a professor at Dartmouth said, this revolutionary technology is transforming the landscape of manufacturing everywhere. So pretty exciting. McKinsey, management consulting firm, says that it's one of the most revolutionary technology applications in manufacturing. So without a doubt, 3D printing has already changed the world of prototyping. It's now starting to change the world dramatically of production, and now's the time to dive in. So next on the agenda, let's talk about design freedom. What does 3D printing bring to the table from a design perspective, specifically for designing new products and new assemblies and components within products? I wanted to throw this picture up because it really showcases, just as the Carbon 3D picture showcased, the new fabrication technology and approach that you can achieve with 3D printing that just simply can't be made any other way. Carbon's part was a sphere within a sphere within a sphere. You can't make that with molding or any other subtractive method. Here's a part of a bone structure that's being mirrored and mimicked by 3D printing, and it can only be made this way. So when we talk about design freedom with 3D printing, we're talking about moving towards a world where we can design for function. You can design for the actual function without making compromises for manufacturability.
Thank you for watching this webinar preview from 3DO. To view the full webinar, please click the link in the description below. If you'd like to learn more about 3DO, please visit our website at www.3deo.co.